Hello, biochemists. This is the video walkthrough that I'm going to do for your second exam. For both parts of that second exam, I'm going to share my screen and I'm going to walk through this over a series of videos. What I'm going to do is break it down into smaller chunks. So as you can see, this is your exam 1.2. First questions 1 through 25 correspond to the old stuff, and then 26 through 50 correspond to the new stuff. So I'm going to do the old stuff first and then the new stuff, but I'm going to break it down into a couple of different chunks. So without anything else to say, your first question reads, which component is found in plants but not animals? And so we've got glyoxysome, lysosome, Golgi, and the rough ER. The Golgi apparatus, the rough endoplasmic reticulum, and the lysosome are all found in animals. It's only the glyoxysome that is found in plants, but not in animals. Next up is which type of organism uses H2O to reduce CO2? We've got green bacteria, purple bacteria, protists, none of these. And this is a question that really goes back to that kind of tree of there was a tree of life and different and the correct answer for this is D, algae. The next question, the group shown below and highlighted is an example of, we've got a carbon double bonded to an oxygen to a single bonded oxygen with a negative charge. This is a carboxyl group, carboxylate ion, specifically what's shown there. Number 4, the functional group shown in the question above will have which of the following charges? Well, it's already showing a -1 charge. Now, when that group is protonated, it's going to have an overall charge of 0. So B is the correct answer for number 4. Number 5, chromatin is a supramolecular complex that consists of which monomeric units? And this is nucleotides and proteins. So the correct answer option is B. And you know, a nucleotide does have a sugar in it, ribose. However, that's not really a good example. If you selected C, that would not be a good answer just because nucleotides, protein and nucleotides, answer option B is offered as an answer option. Okay, number 6. Fructose is the common name for a simple sugar. It is also known as a fructose, which is so fructose is an example of fructose is sometimes referred to as the ketose version of glucose, glucose being an aldose. It is a ketose and it has a total of 6 carbons. Glucose also has 6 carbons. So the best answer for this is E, and a ketohexose. Okay. Number 7, how many chiral carbons does cyclic glucose have? I think what I'm going to do is just a video for this page and then a video for the next and so on. So that will give us a total of 3 videos for this first exam, or this first part of the exam. Cyclic glucose. Now this is a cyclic glucose. You're going to have a total of 5 chiral carbons because if you remember, linear glucose has 4 chiral carbons. Whenever you cyclize it, carbon number 1, which was not chiral, becomes a chiral carbon. So we're looking at B5 as the question number 7. B5 is the correct answer. An aldopentose is designated as L or D based on the positioning of the hydroxide group on which carbon? An aldopentose. An aldopentose, we are talking about something that has a total of 5 carbons. Our second highest numbered chiral carbon would be carbon number 4. So the correct answer for this is C, 4. Question number 9. All the linear aldoses, regardless of length that we discussed, had an achiral carbon at which position? So an aldose that we discussed, or aldoses that we discussed, that carbonyl carbon or that achiral carbon is on carbon number 1. Number 10, so 9 is A. I'm checking my key just to make sure that I have it all keyed correctly and I don't make any mistakes. Number 10, what is the best definition for a pair of linear sugars which vary by the positioning of one hydroxide group? And the best answer for that is B, anomers. Number 11. Okay, there's a first mistake. You need to correct that one. Oh, wait, no, it's not. I made a mistake of a mistake. Okay, so question number 10. A pair of linear sugars. The key word is linear. And the correct answer for that is epimers. Now, sugars can vary, or anomers are sugars where the hydroxide group varies when we're talking about a cyclic sugar. Number 11, linear glucose cyclizes because its carbonyl carbon reacts with an OH group on carbon number 5 to form what is known as a linear glucose. The best answer for this. So ketal and hemiketal are attractive answer options, but if we have an aldehyde or an aldose like glucose, then what we're doing is we're forming a hemiacetal. Now, the best answer, so that's going to, or a hemiacetal would be a good answer, but hemiketal is what a ketose forms. Now, this is carbon number 5, and so that means that we have a 6-membered ring. And so our best answer is for number 11. Goodness, what is... When we form a 6-membered ring, we are forming a pyranose. So linear glucose, so carbon number 1 reacts with a hydroxide group on carbon number 5. So the members of the ring are carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, hydroxide group on carbon 5. So the 6th member, so a 6-membered ring, we're forming a pyranose. The Haworth projection below is shown, or sorry, the Haworth projection below is first of all, we're presented with a couple of different options. One option, specifically answer option B. B presents you with glucose as a part of your answer. Now, this is not glucose. And why is it not glucose? Well, it's not glucose because carbon number 3, which is this one right here, the hydroxide group is pointing downward. Carbon number, this is the C3 epimer of glucose. So answer option B is out of the picture there. So I'm going to strike that. Is this a furanose? This is not a furanose. This is a 6-membered ring, so it is a pyranose. So then we're left with, is it an alpha or a beta sugar? And what we're looking for is my hydroxide group pointing upward, or is it pointing downward in this Haworth projection? And since my hydroxide group is pointing upward, we're talking about a beta sugar. Oh, oopsies. Beta sugar. So D is the correct answer for question number 12. Going crazy, just a sec. It's going crazy there for a moment. My key, okay. That's why I do it in this sequence. So number 12 is D. There we go. Okay, good. I'm going to go ahead and stop here. I'll see you in the next video.